Alright, hey guys, welcome back to another edition of Algebra 2. Mr. Anderson here with you. We're in section 5.3, talking about polynomial functions. Okay, so let's just get right to it. Our objectives for this lesson: number one, to evaluate polynomial functions and to identify general shapes of the graphs of polynomial functions. Okay? Alright, so first of all, we're going to talk about degrees of a polynomial and the leading coefficients. Okay? So when we're talking about this stuff, we're talking about a polynomial in one variable. Okay? So remember, we talked before about what makes up a polynomial. All the same things apply, and I'll review them here, but it has to be in one variable. Okay? So what does that mean? Well, there can only be one variable. So if you have an x and a y, that's not a polynomial in one variable. Then besides that, the other rules have to apply as far as being a polynomial. So remember, you can't have a square root of a variable. That means it would not be a polynomial. You can't have a variable in the denominator of a fraction. Again, that would not be a polynomial. And no negative exponents, because remember, if you have a negative exponent, that means it flips it to the bottom of the fraction, so you'd have a variable in the denominator again. Okay, so that's what it would take for a polynomial in one variable. When we're talking about these polynomials in one variables, the standard form basically is where the exponents are in descending order. Okay, so when we have a polynomial in one variable, we want to write it in descending order. And when it's in descending order, the degree of the polynomial is just the biggest exponent. That's all. So the degree is just the biggest exponent, and the leading coefficient is just the coefficient of that first term, the term with the biggest exponent. Okay, so pretty simple. Let's take a look at a few examples here. So it says state the degree and leading coefficient. So let's take a look at this. Okay, first of all, when I look at this, I go, is it a polynomial in one variable? Z, yes. Everything else looks good. No variables in the denominator, no square roots, no negative exponents. So this is a polynomial in one variable. It's already in descending order. Look at 3, 2, 1. So we're looking for the degree. So what's the degree? The degree is the biggest exponent. So in this case, the degree is 3. And the leading coefficient is the number in front of that, which is 7. That's not too bad, is it? As far as Algebra 2 stuff goes, that's pretty easy, right? All right, let's look at the next one. You look at this and you go, look at this, A and a B. There are two variables, so this one is not a polynomial in one variable. And why not? It's not because there are two variables. Okay. One more. All right. Now be careful, because sometimes they're not in descending order. And so this is where people usually get tripped up on this, if they get tripped up, because these need to be in descending order to know what the degree and the leading coefficient are. So notice, look at 5, 2, that's a 0 counts as a 0 degree, and then 6. So basically we want to probably write this in descending order first. So this comes first, the negative stays with the 8. Negative 8, x to the 6th. Then we have plus 3x to the 5th. Then plus 2x squared. Then minus 4. So now that I've got it written in that order, what's the degree? The degree is 6. And what's the leading coefficient? Negative 8. Okay. So really not too difficult there, but you do have to have it in descending order. That's the key to that one. Okay? All right, next, evaluating a polynomial function. Now we've done this several times before, and recently we've basically done this using synthetic. But just briefly want to touch back on this again, the original way that we had done this because of what's coming next. So remember the original way that we had done this is we just would plug in the 3 here for x and then plug in the -2 for x. Pretty simple. We've done this many times before, but I'm just going to review that because in the next slide we're going to use that in a little different way. So I've got -2, so I'm trying to find f of 3 here, right? So x is 3, so -2 times 3 to the third plus 3 times 3 minus 12. And so this ends up being, what's 3 to the third power? 3 times 3 is 9. 9 times 3 is 27. So this is really -2 times 27. 3 times 3 is 9, minus 12. And so 27 times a -2, looks like that's going to be a -54, plus 9 minus 12. And let's see here, I'm just going to combine the negatives first, because so I can add them together. So that's a -66 plus 9, it looks like. And so then basically we're subtracting those, except our answer is going to be negative. And so that would be a -57. Okay, remember how we've done that before. And then same thing with -2, just briefly. You plug in the -2, so -2 times -2 to the third plus 3 times -2. We've got -2 to the third, so -2 times -2 is 4. 4 times -2 is -8. This is going to be -6 minus 12, 16 minus, I'll just combine these to make it a -18, and so that's going to be -2. Okay, so just a quick review on that, not real difficult, but here's why I just wanted to review that. What you'll be asked to do is you're given a function, like you see here. We've got two functions. We've got the f of x function here, and then the g of x function. And you're given not numbers, but you're given some variables to plug in. Okay, we follow the same exact thing we did before. We're not going to come out with a number at the end like -57, but we're going to simplify whatever we can. So we've got g of 2a, so I'm going to plug it into this g function over here. So I've got 3 times, remember what's in here is what x is now. So wherever we had an x over here, I'm going to plug in 2a. So this is going to be 2a squared plus 6 times 2a minus 10. And we're just going to simplify this as much as we can. And so we've got 2a squared, 2 squared is 4. So this is really 3 times 4a squared plus 12a minus 10. And then here when we multiply this, 3 times 4 is 12. So we have 12a squared plus 12a minus 10. Okay, so that's all we're doing there, just plugging in that for x, in this case the 2a. All right, the next one, little trickier here, because you look at this, you're like, oh, what's going on here? This is getting a little crazy. Here's basically all that's happening is f of y squared, basically that's, you're going to plug it into this f function here. Think of it this way, just put a little bracket around that. So you're going to do this part in here, f of y squared, which means plug y squared in for x up here. Work that out, and then whatever you get, multiply it by 4 at the end. Okay, so when there's a number in front, that's all it means, is just work out this stuff, then multiply it by 4 at the end. So what's f of y squared? Well, it means we're just going to have what? 4 times, instead of x squared, it's going to be y squared squared minus 3. So what's y squared squared? What's that, Drew? Y to the 4th? Good. So 4y to the 4th minus 3. That's f. This is f of y squared, but I want to find out what's 4 times f of y squared. So then all I have to do is I have to take this stuff here and multiply it by 4. So I'm going to take the 4y to the 4th minus 3 times 4 and just distribute the 4. So that's going to be 16 y to the 4th minus 12 is what you would do there. That's a y, by the way. Whoop. Nice, huh? Okay, last one. F of x plus 3. All that means is plug in an x plus 3 in place of x. Again, we're looking at the f function, so that's this one up here. So I'm going to plug that in. That means it's going to equal 4 times x squared, but now it's what? X plus 3 in place of x. So x plus 3 squared minus 3. Now, okay, we've talked about this very recently. What happens when you take a parentheses here that's like a binomial and you square it, write it twice, and FOIL it, right? And so we're going to do that first, and then we've got to go times 4 there. So here's what we have. X plus 3 times x plus 3. FOIL it. X times x is x squared. Outer would be plus 3x. Inner, another plus 3x. And last would be 9. And so then we have to take, well, let's combine the like terms here. So x squared plus 6x plus 9. But we have to take that times this 4 here. And then we also have this minus 3 out at the end too. And so let's finish this up here. We're going to distribute, and I guess I'll just jump up right up to here. So this is going to be 4x squared plus 24x, and then 9 times 4 is 36. So you have the plus 36 and then minus 3. So then we can combine the 36 minus 3. So in the end, we've got 4x squared plus 24x plus 33. That's what we end up with there. Okay. Hopefully that's not too bad. All right, next. Whoa. Okay. This is probably something you haven't seen before. So this is going to be a little trickier. So stay with me here. Once you get the hang of this, it's not terribly bad, but a couple of things here about the graphs of polynomial functions, okay? First thing to know about polynomial functions are that when you look at the graph, in this case here, both of the arrows are going up, and here both of the arrows are going down. Whenever the arrows are both going up or both going down, you have your degree is even. In this case, this graph, it's a degree of 2, x squared. You know, if you had x to the 4th, it might look something like this. You might have an arrow and it might go woo. Okay, that would be arrows both going up, but this would end up being an x to the 4th graph. Okay, but both going up. You notice over here, when the degrees are odd, the arrows are going opposite ways. One's going up and one's going down. Here, same thing. One's going up, one's going down. So odd functions, the arrows always go kind of up and down. Even functions either both go down or both go up. Okay, so that's the first thing to know about these. You notice here again, this is something we've talked about before. If your arrows are both going up, your leading coefficient is positive. If they're both going down, it's negative. On the odd ones, leading coefficient's positive. It's going up to the right, down to the left. And if it's negative, it's going down to the right and up to the left. So it kind of switches around there. Notice, I'll come back to talk about all the stuff in the middle because that's the hard part there. Notice on this one, the blue line here, the domain are all real numbers. If you take that graph and you like flatten it down to the x-axis, it fills in everything. But the range, remember the range is going up and down, take that same graph and flatten it into the y-axis, and what do you have? Basically, it's all the numbers starting at 0 and going up. So it's all of the real numbers that are greater than whatever the minimum point is here. That's just totally flipped around on this other one down here, where it's all the numbers less than a maximum point. And of course, on the odd ones, both domain and range are all real numbers on both of those, everything. Okay, let's get to this tough part here. All right, all this means, so I'm going to go back and I'm going to erase my red line here, I think. Whoop. Oh, look at that. All right, here's, when you're looking at this, you're looking at what they call the end behavior. Okay, the end behavior. So basically that means where the arrows are going. Okay, so this sign here, the sideways 8, is infinity. Okay, to infinity and beyond. Okay, Buzz Lightyear, if you didn't know, Buzz Lightyear. So on the x-axis, what if we keep going to the right? That's infinity in the positive direction. This would be a positive infinity over here. If we're going to the left, that goes to infinity, but it goes to a negative infinity. Okay, does that make sense? So you got your positive infinity and your negative infinity. But then going up and down, and this is f of x, which remember really just means y, that if you're going up, you're going to infinity, you're going to the positive infinity, and if you're going down, that's negative, and so that's going to be your negative infinity. Sometimes it might help to write this on your graph here, because now what's going to happen is, if I'm looking at this arrow here, this is the arrow I'm looking at to see what happens to it. Where is it going? Okay, it's going up to the right. So basically it's between the positive infinity and the positive infinity. And so this is just kind of, somebody came up with this as far as the way to write this stuff. And so it's always f of x, and then this arrow means f of x is approaching positive infinity as x is approaching negative infinity. And here f of x is approaching positive infinity as x is approaching positive infinity. So you're always going to write that, all you're going to change each time is the positive and negative, which ones are the positive and negative infinities. So f of x is your y. Okay, so if we're looking at this arrow over here, the f of x infinity that we're trying to find is what? This one right here, positive infinity. And by the way, if you haven't figured this out already, this arrow over here applies to this stuff. So I'd say as f of x is approaching positive infinity, that's all this right here, that is approaching positive infinity as x, so on the x we're approaching this positive infinity. So the arrow is in between the two ones that you're going to write. Okay, this is the positive infinity for f of x, that's the positive infinity for x here. Now if we look at the other one, that's going to be, let me change colors here. Oh, there we go. Uh-oh. Okay, hold on. There we go. Let's go to, let's do something like, it would be easy to see, a green. Okay, so now let's look at this one right here. That arrow there is this stuff. So that arrow goes in between what? This positive infinity and that negative infinity. So the f of x, what's going up and down, f of x is going to positive infinity. As x, it's going to be this one out here, goes to negative infinity. So if you write where the positive and negative infinities are, and wherever the arrow is going, what you're gonna put in to your stuff here is the ones that are on each side of your arrow. Okay, so it might take a little while to really get this down, but stick with it. Once you get it, it's not too bad. Okay? So that's the end behavior. And then the other thing to know about as far as a polynomial function are the zeros. Remember, the zeros are where your graph crosses the x-axis. We've talked about that before. So, you know, if you had a graph that looked like this, that would be an odd degree function. And it would have what? 1, 2, 3 zeros. We've talked about that before. And so what they're saying here, this is just kind of a little thing, nice thing to know. Odd degree functions always have odd number of zeros. So this was a third degree or an odd degree function. It has 3 zeros. It could also have something like that, which would give it 1, 0, which is still odd. Now there is one possibility here that could happen, both for even and odd, and it's kind of, I guess, a technicality here. But if you had this, and let's say it did like this, and then came down and hit right there, and you might think, oh, there's 1, it looks like 2. Well, technically, whenever this happens and it comes down and hits this point and goes back up, that's what they call a double root. I'm sure we'll talk about that a little later on at some point. But so technically, in this situation, there still are an odd number of zeros. It's 1 here and then a double root, so 1, 2. Kind of it's just both your zeros are the same thing on that one. So and then the same thing with even degree functions. You're either going to have even number, you know, like an even might look like this. So you've got 2, or possibly you could have no zeros, which would mean like if your graph looked like this, it doesn't cross at all. Okay, so just a couple of things to be aware of. All right, let's take a look, a couple more examples and we're done. I'm going to change back to red, I think. Ink color, red. All right, so here's the couple of things that we have to do. First of all, describe the end behavior, and then is it odd or even, and state the number of zeros. I usually like to start with the second and third ones because those are really easy to start with. So is this an odd degree or an even degree? If they're both going up, that would be even. Okay, so that's easy. It's an even degree. How many zeros are there? Well, you just look, you go, well, there's 1, 2. So 2 zeros. So it's even degree, 2 zeros. And this is the hard part, the end behavior. Remember, this is positive infinity. That's positive infinity, negative infinity, and this is a negative infinity. So then what we want to do is let's just look at where these arrows go. Here's the first arrow. So here I would say f of x is approaching what? F of x is going to a positive infinity as x is approaching or going to what? It's going to a positive infinity. So that tells me about this end behavior. And then on the other one, I have f of x is approaching what? So also, if it's this one now, so it's also going up, so going towards the positive infinity as x is approaching what? And this time this is also going not only up but to the left, so it's approaching negative infinity. So this would be, I don't know why that was so sloppy. So that would be your end behavior that you would describe there. Okay? So again, it's the same format here. F of x, the arrow, and as x, and then the arrow. You're just changing what infinity each one is going to depending on where your arrow goes out here. Okay, one more. Last one, okay, same thing. Let's just start with these other ones. This one, you got an arrow going up, an arrow going down, so that would be what? Even or odd? That would be odd. So we have an odd degree polynomial. How many zeros on this one? Well, you look, you got 1, 1, 2, 3. So we have 3 zeros. And now we want to describe the end behavior. And so again, let's just write these in here. So we got positive infinity, and then down here is negative, and over here is negative. So again, we just say f of x is approaching what? Let's look at this arrow here first. It's approaching, f of x is going where? That arrow is going up, so it's approaching positive infinity as x is approaching, and again, it's not only going up, but it's going to the right, so it's approaching positive infinity. That's that arrow. Now let's look at this arrow down here. So in that one, f of x is approaching, now since that's going down, f of x is approaching a negative infinity. And at the same time, it's also going to the left, which means x is also approaching a negative infinity. So that would be your end behavior on those. All right, so I think most of that's not too bad in this lesson. You know, this stuff here with the infinity stuff, okay, a little challenging, but you know, just keep working on that, and it shouldn't be too bad once you kind of get the pattern down. It's just you're just putting in different infinities and beyond, of course. All right, well, thanks for joining me. That's it for this section, and we'll see you next time. Mr. Anderson signing off. Sayonara.